Okay. We're going to now do 5b from the log test. Now 5b is a little bit different compared to 5a because there is no number that's by itself. So it's actually quite simple. It's simpler than 5a. Where we had the +3. Okay, so in this case, everything is already in ln. On a side note, for those of you that don't know what ln is, again, ln is the log of base e, which is the log of 2.71, the number keeps on going. All right, in this instance right now, we're going to literally rewrite this as a single log on the right side. So we're going to apply the properties of logs, which is a plus becomes a multiplication. So we've got minus x plus 6 times x minus 1. Okay, at this point, I'm just going to go through the process of doing the multiplication. So this is, of course, FOIL. So we're going to do this with this and then that with that, in case you forgot. So it's minus x times x, which will become minus x squared. Minus x times minus 1 is positive x. 6 times x is positive 6x. And 6 times negative 1 is negative 6. And then I close the brackets. Now I'm just going to keep on rewriting it to simplify. So ln minus x squared plus 7x, and this becomes minus 6. At this point in time, because both sides are ln, we can cancel out the lns and just work with what is left, which is x plus 2 is equal to minus x squared plus 7x minus 6. And then we'll just bring all the numbers to one side. So we can write out either this on that side or this on the other side. So I'm going to go with bringing the x over here. So this will become x squared minus 7x plus 6 plus x plus 2 is equal to 0. When I simplify, it becomes x squared minus 7x plus x makes minus 6x. And 6 plus 2 makes positive 8 equals 0. If I do the factors of 8, I do 1 and 8, 2 and 4. My answer has to be positive. My b is negative, and therefore my other column will be negative. So my answer is x minus 2, and x minus 4 equals 0. And then x equals 2 and x equals 4. Since both are positive, both are potential answers. I'm not even doing the restrictions. I just wanted you to get 2 and 4. All right, moving on to the next number. The next number was the problem with the exponential function. Okay, so number 6 said, find the rule of the exponential function with an asymptote of y equals 1 and passing through points negative 2, 74 and 1 comma 0.4. I put such ugly numbers because actually I know it worked out really nicely. First thing you're going to do is establish your exponential formula. And you're going to plug in the points that you see. So this is x1, this will be another point, and here we'll do it for the second equation. It has nothing to do with linear equations. I'm just labeling them as point 1 and point 2. So in the first case, I'm going to put what I know. So I know that the asymptote is going to be k, which is the y equals 1. So I'm going to replace the y with the 74 equals ac to the power of negative 2 plus 1. That's equation number 1. So this is equation number 1. And for equation 2, we're going to have this point. So it's going to be 0.4 is equal to ac to the power of 1 plus 1. So that's my equation 2. I'm going to simplify these so that this one's going to be 74 minus 1 is equal to AC negative 2. Actually, I just realized this should have been a minus 74. So that's a minus 74 minus 74. I had copied it wrong. So there we go. This becomes minus 75 equals AC negative 2. And this becomes 0.4 minus 1 equals AC 1. Negative 0.6 equals AC 1. And now I have my two equations. You have many choices right here. You have a system of equations, so you want to equate the two equations. Now, you could either isolate for A, or you could do it in another way, which is what I had showed you guys before. So I'm going to, generally I like to put the bigger exponent on top so that I don't have a negative exponent to work with. So I'm going to put, actually, I'm sorry, I'll just erase this, make this a little bit more clear because I want it to be visually appealing. So I'm going to just write it over here. So this one has an exponent of 1, and this one has an exponent of negative 2. I prefer to put the bigger exponents on the top, just for simplifying my life. You can do either way. So negative 0.6 is equal to AC1, and negative 75 is equal to AC negative 2. At this point in time, we could cancel out the A's, and we're going to subtract the exponents according to the division properties. So this becomes negative 0.6 divided by 0.75, I believe becomes 0.008, and 1 divided by C negative 2 is going to become 1 minus negative 2, which essentially is 1 plus 2, so it's C to the power of 3. Now you want to cubic root your C to the cubic 3, cubic root this, and your answer becomes 0.2 is equal to C. Now all you have to do is plug in this into one of the two equations to get your A. So I'm going to do that in the next slide. So we have y is equal to, wait, I already forgot. Oh yeah, so it's 0.4 is equal to AC1. Let me go back. Short-term memory problems. 0.4 is equal to AC1 plus 1. We know that C is equal to 0.2. You're going to plug that into here and solve. So we actually had 0.4 minus 1. I could have just applied it before, but I didn't. So that's okay. A, and then it's 0.2 to the power of 1. And now 0.6 divided by 0.2 is equal to A, which makes negative 3. Therefore, your final equation is going to look like this. Y is equal to negative 3, 0.2, x plus 1. Okay, that's the end of that question. Moving on to number 7. So number 7, the question was, an open container contains 10 liters of water and it's evaporating at a rate of 2%. Evaporation at a rate of 2%. So basically it said rate of 2% of its volume every 2 hours. Okay, so our initial value is our A, which is 10. Our multiplicative factor is going to be 100% minus the 2%. So you're going to have 98%, which of course you need to put it into a decimal form. And then your B is every 2 hours. Now, since our unit of time is going to be hours, then your B is going to be X over 2. So this is really important. You're going to write down your formula now. And your formula, I'll just write it here in green. So it's Y is equal to 10 0.98 x over 2. Now the question is, in how many hours will this be 4 liters? So in how many hours, so we're looking for an x, will the volume be 4 liters? Okay, so in that case, we're actually looking for the y, which is the volume of water, or whatever it was. Okay, in this case, we're going to put the 4 in the position of the y. So it's going to look like this. 4 is equal to 10, 0.98 x over 2. I'm going to the next screen so I can solve it. So again, 4 is equal to 10, 0.98 x over 2. So you're going to divide, of course, what you can. And this becomes 0.4 is equal to 0.98 x to the power of 2. Now here's your choice. You either recognize that this is an exponential function and you label them as this is your exponent, this is your base, and this is your answer. So you will write out the word log, and then you put your base on the bottom. You put your answer over here and equals to x over 2. Of course, once you write it like this means that you're going to do the log of 0.4 divided by the log of 0.98, and that should give you x over 2. When you actually do this on the calculator, you get something like 45.35 equals x over 2, at which point you cross multiply and you get 90.7 equals to x. And that's how you do number 7. Moving on to number 8. This is the last question we had on the test, and it was the longest, but it was really satisfying once you did it. So it said, a microbiologist is studying 2 bacteria populations. Last Monday, the first population of bacteria, however you pronounce it, had 2,000 bacteria. And the second population had 2,048,000. It said he noted that the first population doubled twice a day, and the second population, it was reduced by 75% every 2 days. Okay, so you have to establish the first equation. So the A is 2,000, your initial value. Your multiplicative factor is the fact that it's doubling. Your B is it's happening every day, but it's happening 2 times because your X is going to be days. And now here, of course, your Y is going to be your bacterial population. Here, your A is going to be your 2,048,000. Your multiplicative factor, well, it's reduced by 75%. So it's 100 minus the 75%, which is equal to 25%, which of course you're going to put it as a decimal. And you're reducing it. So your X is going to be days again. But this time, your Y is still bacteria. But your B, I'll put it over here. Your B is going to be every 2 days. So it's going to be X1 over 2. So your B is actually 1 over 2, not X over 2. My mistake. There we go. So it's going to be 1 over 2 because you're going to multiply it by this. So essentially, on the next screen, I'm going to just put the 2 formulas. And you want to know after how many days will the population of bacteria be equal in number. So you want to equate your 2 equations because you want to know when will they have the same population. So every time we're talking about same population, you're going to equate them. So you're going to write first equation. So first one is 2,000 to 2x, and you could say y is equal to. And the second one, you could say y is equal to the 2,048,000 times 0.25 x over 2. Okay, now that you have them both, you're going to equate them. This is where it gets all fancy because we're going to be doing logs. And this is probably the most interesting type of questions and that you will get on the exam as well. All right, I see a 2,000, I see a 2,048,000. Right away, I'm going to try to simplify my life by dividing this by the 2,000 so I can get a nice number. Most of you did this, so most of you already knew to figure that out. And so you ended up having 2 to the x, and you have 0.25 x over 2. All right, this is about as simple as it gets. Once we're here, what are we going to do? We're going to log both sides. You're going to do log of your 2 to the x is equal to the log of 1024 times 0.25 x to the 2, I guess, like that. Now, I'm going to go on the next page. So I'm just going to rewrite that. Log of 2 to the 2x is equal to the log of 1024. I'm going to apply the property of addition. So the log of 0.25 to the power of x over 2. Okay, remembering properties where I pull these exponents to the front. So I'm going to pull out, I have a choice. I could pull out the 2x or just the x and leave it as 2 to the power of 2. I'm going to pull out just the x and then do log of 2 to the power of 2. I'll just leave it like that, is equal to the log of 1024 plus, I'm pulling out only the x, and I'll do x, or I'll just write it in red so that you recognize it. There we go. Log of 0.25 to the power of a half. Okay, now I'm going to put all my x's together. So x log, this one here is 4. And I'll bring this one over, so it becomes minus x log 0.25 to the power of a half. If we do 0.25 to the power of a half, it becomes 0.5. Just put that on a side note over here. So 0.25 to the power of a half equals 0.5. That's where I got this over here. Now, this log of 1024 stays on that side. So this x over here, I'm going to factor out my x's. So x, open brackets, log of 4 minus log of 0.5. I really don't want you using a calculator yet. The fact that you can go to the end with that one is what shows that you know how to do this. At this point in time, I'm going to apply the properties and make this a single log. So it's 4 over 0.5 because a minus becomes a division, and then log of 1024. Now 4 divided by 0.5 is the log of 8 over the log of 1024. And if you do this now, we want to isolate the x. So x is equal to the log of 1024 divided by the log of 8. And I believe that gives us 3.33 days. Let me just verify my calculator to make sure that that is the answer. And I can't even find the log button on my calculator. Oh yeah, second function log of 1024 divided by second function log of 8. Yep, 3.33. And that is the final answer. Hopefully that has been helpful, and I'm kind of liking these little videos I'm making.